Okay, thanks for the introduction. And I want to give a shout first because he talked new features and how they work with us to get those new features done. And I'll also be talking about how, as the open source maintainer, how you can make new features possible in your open source. So it's a pleasure to be here tonight. Yeah, I'd also say that there's a lot of QR codes today. You can scan them, but at the end there'll be a link to just download the slides outright, so you'll be able to do that. Anyway, said, my name's Tim Larkin. I head development at Ænix. That's the company that initially, and part of my job is being a Cozystack maintainer. Sometimes I have to reject pull requests. When some crazy bloke in and rewrites the API completely. So in a way, I'm responsible for keeping our architecture simple enough to reason about, the code base reasonably clean, creep and check, and so on. Now, this keeps the code maintainable. It reduces our workload. And we're lazy. Well, I mean, of course, we are lazy as all developers. We have to do this because we care about the success of code. Talk about the challenges we face building Cozystack, the pitfalls that we fell victim to, what we learn from our mistakes and from other success. We were able to apply this to grow Cozystack. So the challenge, Cozystack to be a platform for one, from the regional provider to the home labber, and for all the enterprises in between that want an internal developer platform, and so on. You can imagine the challenges that we face. The home labber experiments with a few VMs on a single server. The cloud providers probably run in the enterprise, they may whatever, a hybrid cloud setup with some proprietary SDN. So I told include them in Cozystack core. Do we add a million configuration options that will cover every use case? We can actually, if we should, but can we actually pull this off? I mean, the very same user that demands support hardware firewalls and also demands that the platform is easy to use, that it is simple. And of course, above all, each platform not to lose data, not to crash in some endless reconciliation loop. Every user expects it to be reliable. This is already quite a challenge, but we're an open source project. We can throw more developers at the problem and build all the features. Now, at Ænix, we maintain an operator to launch etcd clusters. It's a fun. You can spin up an etcd. It can do a little bit of self-healing, and in fact, we're happy to use it to launch etcd clusters for managed Kubernetes. New features into it. Why might that be? Well, usually it starts like the spec that defines the top level things like replica count and whatnot. Let's throw in some options for every individual replica. So what should we put into this option struct? Well, maybe a couple of fields to adjust for the RAF protocol. After all, who knows? Someone's running etcd across multiple availability zones. Is a bit higher, so you got to account for that. So we do it. We add a couple of fields here. What if someone is bottlenecking etcd, they're running it in a high to debug? Well, why don't we add a flag to enable the pprof endpoint? Well, if you're going to add stuff like well, add an option to turn up the log levels to debug. That'll be useful. Then with an interesting use case comes along and says, okay, run ephemeral etcds, I need to spin them up quickly, I don't care about I just need to test this stuff fast. I want the force new cluster flag. We add this, and now, this is kind of out of hand. Okay, yeah, screw it, and you do this. Okay, now you don't have to implement the other piece. Sounds good. Besides that, you no longer have type safety for the options. Now the users can break things in now, could some simple command line flags done all that damage to our really? But yeah, we went and did this. I mean, what if the user wants to annotate the resources? That's like, maybe he's got company policy that every resource should have a certain annotation. What if the user, because that's how they collect, scrape, and ship logs to their log storage. Maybe they're not happy with the budget restrictor, so they need control over that. So we expose all the internals through templates for all. And yeah, we really added these templates for absolutely everything. And we did this quite early in the project. It's my belief that this was growth. So instead of working on the core features that we needed to push out, we later ended up spending many man hours reasoning about edge cases, which were brought about unbounded customization. Now in Cozystack, we do not expose these options to the end user. etcd deployed by hides most of these knobs from the user. And so the entire spec amounts to just 4 strings and 1 int. The knobs do not give us more power. In exchange, we merely get more complexity. Basically, it gives you so much more in return. Now, this kind of philosophy is all too familiar to the developers of the programming language. It's a very simple language, and part of the reason that is the case is because the Golang developers consciously, and for example, some other languages have looping constructs, like C has a do while, C has a while loop, so has the with Go, that is not the case. Go has just a single loop, that is the for loop. Of restraint can be observed in a somewhat famous example when the Go maintainers debated with the community about monotonic time the entire years. On New Year's Eve of 2017, Cloudflare experienced a significant outage. It measured a negative time to events. Now, at that time, the Go standard library did not expose a monotonic clock. And when the rollback, the result was that the DNS resolution took negative 900 something milliseconds in runtime, and the postmortem is worth a read in and of itself. You can get the postmortem through this QR code, but still, even though the Go maintainers knew about the problem well in advance, the issue was brought up like about half before the incidents. The major incident happened. The maintainers still exercised restraint because they knew that if they would that would be function, then not rolling out any solution at all. After the incident, it took them another year and a half to monotonic clock into the time package. I like to think of it that they took 3 years, a flame war, to agree that time can only move forward. But I think we can take away some lessons from the way that they. One idea was that they simply create some kind of new API, maybe some new time monotonic, the time struct with some extra methods, such as now monotonic and subtract monotonic alongside the now, and so on. But the problem is with this approach that it doesn't fix any existing code. And many developers, they'll simply they should old time now method, but instead they should use the time now monotonic. And then what's more difficult, you've got the go one promise. So the time struct is part of the standard library. And many other packages in the library use own purposes. Then the networking package that contains a con interface. It represents a network. And this interface, it has that accepts the time as an argument. That's like a point in time in the future when a connection is supposed to time on. Now, you cannot fix the interface to accept a new monotonic time type, because this breaks the existing API and hence the Go one. You cannot face by adding a new method, because that also breaks existing code which is trying to implement this interface. Well, eventually, Go did what Go usually does. The maintainers made the time API simple, simply, and the complexity was hidden in the private methods of the time struct. Now, if possible, a call to the system's monotonic clock inside an unexported field of the time struct. If you'd like to learn more about relation, I highly recommend this blog post from Victoria Metrics. They explain how it was done in Go and explain clock. And there's a few lessons we can learn from this story. Despite being so restrained and so change averse, the Go maintainers, even then, they still have their and it takes a lot of effort to fix that. But they recognized that what makes Go successful is simplicity. I thought that keeping this promise was more important than rushing out a hasty. Over engineering a big new feature, they took the time to evaluate their options, and they found a place where a small surgical change could be for everyone to make things just work. And another one takeaway from into open source, and you encounter some kind of stubborn maintainer who doesn't see the problem, you request your bug fixed, you shouldn't be frustrated, because more than likely that means that you're working with a person who truly like that is software that is worth using. So our creator taught us a lesson about the pitfalls of over-engineering. And the story of monotonic time in Go inspires us. So how did we apply these learnings in Cozystack? Dedicate every other Friday to interesting side projects. On one of these days, I decided to spend some time working on our really developed. So in Cozystack, we use Cilium as part of the networking stack, and it offers us a powerful policy different tenants from each other, but the engine isn't really exposed to the end users. So I wanted to build on this to create a secure like a tool that would work similar to AWS security groups. Now, if we compare AWS and Kubernetes, security groups map cleanly to network interfaces from AWS, those map cleanly to pods in Kubernetes. So the pods is the network identity in a Kubernetes cluster. But of course, nobody wants to work directly with pods, just as generally you don't often direct interfaces in AWS. So to me, a meaningful concept was attaching security groups to manage Cozystack. Just like with monotonic time, there was a straightforward and naive solution. Introduce a security groups field to every app and hope it works. In fact, it could work for most apps, but it sure would be a lot of work to fix everything in our use some operators that don't play nice with that. They don't let you pass down arbitrary labels to the. That was something to be dealt with. And then besides the standard library, there's also the issue of third party, which may satisfy some provide. The thing is, by that time, we knew that we want Cozystack to be easily extensible. Third-party developers apps, which can be orchestrated by Cozystack. Now, if we would go with the naive approach, every managed app would also have security groups, and we wanted to do better. I think what we need to know is what owns what. Instead of trying to force this information from the top down in every app, I wondered if there is a uniform way to which app owns a given pod. And in fact, there usually is. A pod is owned by a controller, like a replica set. Concern is owned by deployment. The deployment will usually have some labels pointing to a Helm release. We can map from a Helm location. Now that we know which pod belongs to which app, we don't actually care about the internals. Controllers that will attach and detach completely transparently to the users and contributors. Now, that this small change more powerful than simply opening the road for security groups. It in implement an API dashboard that was released a couple of versions ago. So we can now realize which application and display only the users. You can think of some use cases with this feature for auditing applications. We basically learned that a small but well-placed change can bring large benefits for just a fraction of the effort. We know that good software must be predictable, boring, simple, reliable, but when a small change just doesn't cut it. What happens if you need to build a big new your users? Developers who want hooks, extension points, because you cannot simply release a stable version 1 and then together. How do you grow without breaking things? From the history of Kubernetes. Now, Kubernetes itself faced challenges similar to those Cozystack is facing today. You may know that Kubernetes actually has a number of in-tree volume plugins for all sorts of volumes, like the AWS or like Azure disks. But who of you today uses anything besides persistent volume claims? Maintainers, they quickly realized that a single clean extension point, the container storage interface with pluggable CSS, much more scalable. But you might ask, why did they even bother implementing the in-tree plugins to begin with? Kubernetes was just taken off. They needed the adoption, and the adoption would only come if they supported different vendors out. Now, in hindsight, that they could have simply started implementing pluggable CSI drivers themselves until they finally got enough to have the vendors pick up the slack contributing as well. But here's the thing. When this was happening, there wasn't a it was created precisely because of the challenges that Kubernetes met. We, however, do have the benefit of hindsight. Of giants and recognize a recipe for success. Have a stable, small core API, like like a regular Lego base plate. Create clean, well-defined extension points, and let the complexity and the versatility rise. You can build on top of a Lego base plate where the developers can innovate. Right now, we're working on a major feature, an API for backups. I like to have a uniform interface to back up any application that might have been deployed. But backups much harder than security. All a security group really is a network policy attached to a pod. They're uniform kinds of applications. Backups, on the other hand, they could not be more different. So, for instance, a virtual machine is by saving a copy of all of its disks. Even that is not so simple. You need to take care to flush all pens in I/O operations, or a command to freeze the VM, and only then can you create a snapshot of the disks. And after that, you can push this data to something like a clustered database, like Postgres. That's a different beast. And I guess you could make physical copies of Everest, but you would need to take a lot more care to maintain consistency across the replicas that you have. Not all databases, they have some means, usually some built-in means, to create logical copy instead of physical copies. Another thing, something like etcd, that creates snapshots of its database automatically. It might be enough to just attach to the pod and ship these files to offsite storage. And finally, some stateless apps, maybe something. There it might be sufficient to back them up simply by backing up the YAMLs that you use to deploy them. I would be happy to be proven wrong. But unlike security groups, it seems like a one-size-fits-all solution. Every app has its own way to get back up. Every app, if you like, needs its own strategy. And that's a hint, because the strategy pattern is a very powerful tool in programming. And thinking of it this way helped me post and discover the API boundaries. So I drew my inspiration from the cluster API. It defines quite a small contract. Create a cluster object, create a machine, you reference a control plane object and an infrastructure object. For cluster API controllers, concern themselves with how a control plane is created or how the infrastructure is deployed. This is the others. These implement their own particular flavor of infrastructure control planes. So you can create a cluster and AWS EC2 instances, or you create a cluster that references a Kamaji control plane and KubeVirt as the infrastructure. So I recognize that a similar approach is possible for backups as well. The core contractors can keep, they define the contracts. Maybe they handle also the upload of the backup. Every X hours, the core controls that the application Y is backed up using strategy Z. And after that, the controller that actually knows to execute a given strategy can take over and actually do the thing. It's still going to take a lot of backups. But now developers that want their application to be backed up and the strategies that they have themselves and without having to push code to the Cozystack core without conflicting with each other. Keep the core of Cozystack stable without stalling progress. And understand that implement some of these strategy-specific controllers ourselves. It is what it is to get the ball rolling. But we took lessons in the industry, we learned from our own mistakes, and we can be a lot more confident that the path will be easier than theirs. I'd like to leave you with these takeaways. And because you think it might be useful. Do it when you know that it will be necessary. Guessing wrong is very expensive and learned with our etcd operator. If you keep the core clean and small, your users will appreciate the simplicity and stability of your product. You don't need to introduce 100 configuration parameters. You will not be smarter than your users. They won't be able to satisfy everyone. Instead, try to give your users a way to add their own behavior. Discover the patterns and boundaries in your design, because a well-chosen pattern is intuitive and easy to use. And the that feels like magic. Thank you.
Please ask your questions in Q&A button.
How can one build a front end for Cozystack? I cannot say that well documented at the moment. I mentioned a couple of one or two versions back. One version back, yeah, in 0.3. We released Open API dashboard, and hopefully that is a start. It's more mature than, and it is customizable with custom resources that are available in Cozystack. So if you're using Cozystack and you want to add some special representation of your custom managed app to the existing representations, you're able to do that by editing the custom control the dashboard. Will be better documented in the common versions. Now, for public cloud is just a dashboard to manage your infrastructure, and I can promise that the entire thing will be even open sourced. Some things are extremely bespoke and only app to this or that client. Some things regarding billing and accounting, that's also quite a special case. But just for the engineer, the management interface for engineers, that's already available. That is open source, and hopefully that will be documented in the future. What is the strategy with keeping up with the Kubernetes version? One version behind or up to date? Okay. So right now we let people deploy most recent Kubernetes versions. We are in a way locked in by Kamaji also itself has limitations on which version of Kubernetes it allows you to deploy. Don't try to bend it. But in reality, we in our the latest and the second latest Kubernetes version. Any advice to authentication to Cozystack itself without logout? I cannot say that I've encountered this problem too often. Now, since Cozystack is usually deployed on top of a Kubernetes deployed by Talos, as long as a valid Talos config, you can always generate a cluster admin kube config and then get everything you need from there. But I think exotic ways to lock yourself out from your SSO provider if you change the default admin password. Well, I guess it's the same as in any other environment. Yes, so basically one would need to integrate with other platforms like a billion and with the public cloud. Yeah, sure. As Ænix, trainers of Cozystack, we do have some enterprise modules that provide for that. You can use, you can write your own a module that someone else might provide. In some sense, yes, you have to integrate with other software to make it completely like sufficient to be a public cloud. Hardest problem in Cozystack. The problem, I guess, is that we always want quickly solve feature, especially when nice folks such as Matthew from Hidora ask for it, and it's hard to resist the temptation to rush something out. Okay, I think my time is up. Thanks for all the great.
Thanks, Tim. Thanks for your great talk.